So dear students, so today we will be discussing about electrochemistry topic. Okay, so I will be making it into the parts, almost like 3 to 4 parts I will be making it. Okay, so in this first part we will be discussing about electrochemical cells. Okay, so now let us have one look into what exactly electrochemistry here. See here we will be taking. So what exactly electrochemistry? So here what we will be doing is by chemical reactions, using some chemical reaction, using generally those are spontaneous reactions. It means there are some set of reactions like redox reactions. So during this redox reaction some amount of chemical energy is released, so that energy will be converted into electrical energy. So what we are doing, using chemical reactions. So what happens, during this chemical reaction some energy is released. So this energy is called what? This energy is called chemical energy. Okay, so this energy will be converted into electrical energy. So this is the process we will be seeing in this electrochemistry. This is one process. And the second one is what? Okay, using this electrical energy, we will be making some chemical reactions. What we are making? Chemical reaction. There are two processes we are making. The first process where chemical reactions are used to make or the production of electrical energy, and one more process is what? So some chemical reactions will not take place on their own, they require some external force, okay, external force or external support. Okay, so those reactions we can call it as non-spontaneous chemical reactions. What is that? Non-spontaneous chemical reactions. Okay, so to these non-spontaneous chemical reactions we need to supply what? Electricity, so that that chemical reaction takes place. Okay, so there are two processes. We will be using chemical energy, the chemical reactions. Using chemical reaction, chemical energy converts into electrical energy, and one more process is using electrical energy, some chemical reactions are taking place. So these are the two processes happens in this electrochemistry, and the study of these two processes will be taking place in this electrochemistry. Okay, so this is what about the introduction part. Okay, so now Vihan, so this will be around some 30 minutes to 35 minutes only. Okay, so you can focus here till the end of the session, it will be definitely helpful for you. Okay, so in this session what I told you, I will be discussing about electrochemical cells. Okay, Vihan, I hope it will be clear to you if you follow it from the starting onwards. Okay, so now this is about introduction part. What I told you, there are two types of reactions involving electrochemical reactions and electrolysis. So what exactly electrochemical reactions here? So electrochemical reactions means, so here we have something called electrochemical cells. What I am saying? Electrochemical cells, that is what we are going to study now. Okay, so in these electrochemical cells, I am writing just EC, electrochemical cells you can say. So in these electrochemical cells, so what happens? Chemical reaction takes place. So this chemical reaction produces some energy called chemical energy, that will be converted into electrical energy. Okay, by a spontaneous chemical reaction, energy is released, that will be converted into electrical energy. That happens in which one? Electrochemical cells. Okay, in which one? Electrochemical cells. Okay, those reactions which are used in these electrochemical cells are considered to be electrochemical reactions. Okay, so now one more thing is electrolysis. So what is this electrolysis process? What I told you, the second part here in this discussion, I have told you that using some electrical energy, a non-spontaneous chemical reactions will be carried out. Okay, so this is the second one. Hope it is clear, both of these are clear. Now let us discuss our main topic, that is what? Electrochemical cell for today. So in the next class I will be discussing about electrolysis and other parts of the electrochemistry. Okay, so now what is this electrochemical cell? It is a device which produces electricity as a result of chemical reactions. Okay, so what is the main agenda here? Chemical energy, conversion of chemical energy into electrical energy. So what are the examples here we have? One is galvanic cell, another one is Daniel cell. Okay, so let us understand these two things now. here, so what happens? So here in electrochemical cells, a redox reaction is taken. So what happens? So in electrochemical cell, in that device, in that cell, we will be taking in that cell we will be taking a redox reaction. Okay, so that redox reaction happens spontaneously and produces energy, right? Okay, so that energy will be converted into electrical energy. Okay, so redox reaction means what? There should be oxidation, reduction, both has to be happen. Okay, so now this oxidation reduction happens in like two separate compartments. So in order to understand this, let us take the diagram. Okay, so I told you it is a redox reaction now. So redox reaction should happen. Okay, it means it should contain oxidation process and it should also contain reduction process. So this oxidation reduction takes place in two different compartments. So two separate compartments. I am indicating them like this. So this is one compartment you can consider and this is another one. Okay, let us take it like this. Okay, so now here in this compartment I am taking an electrolyte. So what do we mean by electrolyte here? Yeah, so what do we mean by electrolyte? It is a solution. Electrolyte solution means something like any salt solution like that. Okay, it should contain free ions. Okay, like this. Okay, so let us say this electrolyte solution is zinc sulfate solution I am taking. What I am taking? Zinc sulfate solution. Okay, so in this I am dipping a metallic rod. So that metallic rod is nothing but zinc rod here. What I am taking here? Zinc rod. Okay, so ZnSO4 is a electrolyte here. What is this? Electrolyte. This is a solution, electrolytic solution, and zinc rod is called as electrode. What is that? Electrode. You have to remember this. Okay, so the next here we will be taking in this another compartment. Here also we will be taking the other solution. Let us indicate with blue color here. Okay, so what is this blue color indicating? This is also solution. Which solution? It is copper sulfate solution. What is this? Copper sulfate solution, and I am indicating the rod with this green color. So what is this green color rod here? This is respect to copper metal. So copper sulfate solution having copper rod dipped in copper rod is dipped in copper sulfate solution. Now these two things has to be connected. Okay, so I am connecting them. So what we are doing now, we are constructing this electrochemical cell. So we are constructing electrochemical cell here in this process now. Electrochemical cell we are constructing. Okay, so we need to connect these two half cells now. This is one half cell, this is another half cell. So for this I am connecting this. Okay, so during this, to measure the current produced, I am using ammeter here. Okay, ammeter I am using. Okay, and here I am using a key, or you can say switch like this. Okay, so these are the two things I am taking here. Okay, so this is what? Key, and this is ammeter, just to check the voltage difference. Okay, so now what we can do here? See, here I have taken zinc rod now. So now what happens is, the zinc is a metal having more tendency to lose the electrons. What tendency it has? Lose the electrons. So therefore what happens, whenever this zinc rod is dipped in this solution, so this zinc has tendency to lose the electrons, means so it will become Zn plus 2. Oxidation takes place and it will be releasing 2 electrons, right? This is what happens. So this is happening in which compartment? This so this side. So wherever this oxidation taking place now, this compartment is called anode. What is this? Anode compartment. And the other one is called, this is called cathode compartment. What is this? Cathode compartment. So at anode what happening? At anode what happening? Oxidation taking place, right? Okay. So now see, at anode what happening? Oxidation takes place. So it means this zinc rod whatever we have, that is becoming Zn plus 2. Now it is not anymore, whenever it is becoming Zn plus 2, now it is not a metal now, it is becoming respect to ion. Now it will be dissolved in this solution. So here it is in the solid form. So here it will be in the aqueous state. Ion. So this zinc rod, what happens? Slowly dissolves into the solution form. Is that clear? Now electrons are releasing from here. Now what we can observe here, now this metal has more tendency to release the electrons now. Okay, so now this metal I am indicating with symbol negative charge. Why I am indicating the symbol negative charge here? Electron density is more here now, so that's why we are indicating negative charge for anode and positive charge for cathode. Hope it is clear. Now these signs are also important. Okay. Neelam, Elia Neelam. Hi, good evening sir. Yes, good evening dear. So please follow the class, and if you have any queries you can feel free to ask. Okay. So now here, so you can see now electrons are releasing at this metal rod. So these are coming towards this side like this. Okay. So they can come to this side, right? So now what you can understand? So flow of electrons are taking place like this, but you are seeing that flow is only for one side, not to the other side. So in order to fulfill this circuit, it is not fulfilled circuit now, it is only half side. Okay. So we need to fulfill this circuit. So for fulfilling this circuit, so we will be using something called salt bridge. What is that? So in order to fulfill the circuit, we will be using something called salt bridge. So that will be indicated like this. So what is this salt bridge? It is a constructed using a inverted U-shaped tube which is filled with agar-agar. So it is a jelly substance. Okay, now see agar-agar powder will be mixed with some solution. So where it also contain some electrolytes, something like KNO3 like this. Okay, KNO3 or K2SO4 like that will be taken. So what it contains now? It contains agar-agar
with some electrolyte.
Agar-agar boiled with KNO3 solution or K2SO4 solution, something like this. Okay, so now it will become a pasty mass. What is this? It is become a pasty mass that will be filled in this salt bridge, in which it will be filled in this salt bridge. Okay, so now what is the use of filling this agar-agar with KNO3 or K2SO4 in this salt bridge? So that will fulfills the or completes the circuit. Okay, so now see, electrons are flowing from here to here, from anode to cathode through external circuit. What is this? This is an external circuit. Okay, so now current will flow from internal circuit from here to here. So now this circuit, this contains what? This salt bridge contains what? Agar-agar with KNO3, K2SO4. So now you should get a doubt now. So why we have to use only KNO3, K2SO4? Why not NaCl? Why not KCl or some other species? Why not some other things?
They are not good electrolytes.
So I will tell you, okay, about that. Okay, so now here it will be containing this now. So now from here what happens? Electrons are flown from here to here. So what it is containing here? Copper rod dipped in the copper sulfate, right? So now what happens at anode? Let us understand here. At cathode I am writing what happens there. So here this copper sulfate solution is there now. So copper sulfate means what is the charge of this copper here?
Cu2.
So this Cu2 plus will take the 2 electrons coming from this anode through the external circuit. So that 2 electrons are taken by this copper plus 2 and becomes Cu. So here whatever Cu plus 2, this will be in the aqueous form, right? So solid form. This is what conversion taking place. So can I say the copper plus ions, copper plus 2 ions from solution deposits on this copper rod? Yes, this is what the scenario happens here. Okay. So now sir, can you say how to start? Came from start onwards. I am long term students. Yes. See dear, I just started these sessions few days back, almost some 1 week back only. Not even 4 classes or 5 classes are done. That's it, right? So you can just go through the playlist of this channel and you can watch everything. Okay, so which is related to the chemistry or any other subject you are required. So you can just go through that and you can watch all those videos, it will be definitely helpful. So just check 100 days challenge chemistry, whatever the videos are there, all videos you can watch, that will be helpful. And if you wanted to discuss more about this, so just contact us to the mobile number provided below here, which is scrolling on the screen. You can contact them and you can connect with us directly. We will clear your queries. Okay, hope it is clear. Now just listen to the class now. Okay, so now hope it is clear what happens. Electrons flow from anode to cathode to the external circuit. Therefore at cathode copper deposition takes place. Okay, so now you should get a doubt. So here what happening, electrons are releasing, Zn plus 2 ions are coming out from this rod. Okay, so now these Zn plus 2 ions are coming out. So if we want neutralize this, what happens, the Zn plus 2 ions concentration will be increases here, therefore the releasing of electrons decreases here. It means we need to neutralize this. It means we need to decrease the charge, neutralize this. So how can we neutralize? Yes, we can neutralize. See here what happening, the copper plus 2 ions are depositing as copper rod. So now what concentration is more here, sulfate ions are remains like this only, right, like this. So here negative charge is getting, concentration is increasing. Now this negative charge won't allow this negative electrons to allow into this anode cathode compartment. So in order to make, or in order to maintain this electrical neutrality, these salt electrolytes are used here. So now these sulfate ions will be neutralized by sending this K plus ions from here to here, and these Zn plus 2 ions are neutralized by sending these nitrate ions into these compartments. Okay, now you should also ask me why only KNO3, why only K2SO4, like this only. So the mobility or the velocity of K plus and NO3 minus, nitrate ion and potassium ion, is same. So what I can write here, the velocity, the mobility or the velocity of K plus and velocity of nitrate ion are almost equal. Therefore whenever nitrate ion moves here, with the same velocity K plus ion moves here, overall makes it neutral. This is what the scenario happens. So that's why we need to use those solutions, those electrolytes which have their mobility or their velocity, or I can say their transport number almost equal. Both cation and anion should be have equal transport number or mobility or velocity, you should say. Hope it is clear why we only using this. Yes. Now this is a total scenario happening in this cell. Okay. So now here, so what is the net cell reaction I should write here? Net reaction, what I should write? See, these electrons are reactant side, these electrons are product side, I am removing. So what is the remaining part? Zinc plus Cu plus 2 gives rise to Zn plus 2 plus Cu. This is what happened. Okay. So now, yeah, so this is, see here it will be in the solid form, it will be in the aqueous, and this will be in the aqueous now, this will be in the solid. You can represent like this. Okay, hope it is clear up to here. Now let us discuss few more things. Now from where electrons will flow? Anode to cathode. From external circuit. Electricity flow from where to where? Yes, so electron flow and current flow will be in opposite direction, you should remember. So from here to here you can remember this side. Okay, electron from here to here. Hope it is clear. Now let us discuss few more things. So this is what we'll be using, KCl, KNO3 will be using in the electrolytic solution, that salt bridge. Okay, so now here few important points to be noted about the salt bridge. So what is the use of salt bridge? Use of salt bridge, you can write bridge to complete the circuit. This is one thing, and next thing is to maintain electrical neutrality, can we say electrical neutrality, and to minimize electrode liquid junction potential, these things. These are the main points you can remember. Okay, so how to choose the salt, that salt electrolyte in the salt bridge?
Mobility should
Be equal, that's it.
for both
Anion and cathode. So these are the net reaction. This is what we have seen there, right, in anode and cathode. So what is a cell reaction representation? It should be like this. Okay, so now this can be represented like this. So cell notation we can say. This is the net reaction. This net reaction should be represented like this. So first of all, that left side what we have taken? Anode we have taken. Okay, and right side we have taken cathode we have taken. In between them what is it is connecting? A salt bridge. So salt bridge is represented like this. Now what happens at anode? Oxidation now. So metal converts into metal ion like this. Okay, like this you need to represent. Now double slash, this represents what? Salt bridge. After this what happens? Metal ion converts into respective metal. Reduction takes place. It means, can you show me the representation for this zinc? So zinc is converting into Zn+2. Okay, salt bridge. Cu2 plus is converting into Cu. So this is the representation of this particular cell. We can call it as cell representation. Okay, very important. Okay, this is clear now. First oxidation, I mean anode compartment, then next salt bridge, then next cathode compartment. That's it. Okay, then next we'll discuss few more things. So flow of electrons takes place from
one beaker
to another beaker through salt bridge, through external circuit. Electricity from internal circuit through salt bridge. This is what we have seen. Okay, so now this, whenever the current, how this flow of current possibility? So flow of current is possible only if there is a potential difference between two electrodes. So we are taking here zinc and there we are taking copper. So there should be potential difference between these two metals, then only these two electrodes, then only current flow will be possible, right? Okay. So now what is this potential difference? In order to understand this potential difference, now what is our question? What is exactly potential difference? In order to understand this potential difference, we need to know about electrode potential. What we need to know? Electrode potential. So what exactly electrode potential? See, why do we need to know electrode potential? See how you have represented cell. Zinc, Zn+2, Cu +2 to Cu, like this now. So see, this is zinc is one electrode, copper is another electrode. If you know their electrode potential, then you can find this potential difference. Okay, that's why we need to study about electrode potential. So what do we mean by electrode potential? In simple words, we can define this as the capacity or the tendency, see, of an electrode to lose or gain electrons. So what do we mean by electrode potential here? It is the tendency of an electrode to lose or to gain the electrons. So losing of electrons we can call it as oxidation. Gaining of electrons we can call reduction. So now here you can write two more points. These are important points. An electrode with greater tendency to lose electrons has more oxidation potential. What we are saying? See, if an electrode having more oxidation potential, it means it is having more tendency to lose the electron. It means it is having more tendency to undergo oxidation. Okay, since it is undergoing oxidation,
What is oxidation potential?
that is what electrode potential, it is undergoing oxidation now. So we can say this is oxidation potential. If it is undergoing having tendency to undergo reduction, we can say reduction potential. Okay, so now since this electrode, for example, I have metal 1 and I have metal 2, so it is having oxidation potential. It means E of E naught, let us say standard oxidation potential of this metal 1, oxidation means metal should convert into respective metal ion like this. Okay, this is something like around some 1.5 volts. Okay, so for metal 2 I have E naught values as M2 converting into M2 plus ion, so it is around 0.5 volt. So which is having more oxidation potential here?
M1.
M1. So which is having more tendency to undergo oxidation here based on the values? Yes. So this is having more tendency to undergo oxidation.
It's a reducing. M1 is a reducing.
So that is what. So M1 easily
Oxidizes itself.
oxidizes itself. It is oxidizing itself means whenever something is reacting with this, that will be undergoes reduction. So it is oxidizes itself and
M2
reduces
others.
others. So what I can say, it is a strong reducing agent. Hope this concept is clear now. So out of this M1 and M2, which is strong reducing agent?
M1.
So here M1 is strong reducing agent than this M2. So what do we mean by reducing agent?
Which oxidizes
Itself and reduces others. So M1 is oxidizing itself more easily because it is having more tendency here as per the values. So easily undergoes oxidation itself and reduces others. Therefore I can say M1 is strong reducing agent. Hope it is clear. Now let us discuss few more things. See, another point, you just generate another point. What I can write? One more statement.
An electrode with greater than
More reduction potential, more reduction